Okay, so have you ever felt that way? Like when you're trying to really get into a complex topic and there's just so much information out there.
Like drinking from a fire hose.
Right. Like you're missing some sort of secret decoder ring to unlock it all.
It can feel pretty overwhelming,
Mm-hmm.
especially in the sciences. It's like, where do you even begin?
Totally. And that's exactly why we're doing this deep dive. We're here to unpack those complex topics and distill them down for you, the learner.
To help you find those aha moments without having to wade through a mountain of research papers.
Exactly. And today we're tackling a pretty fascinating one, the role of writing in learning science.
Yeah, we're diving into a systematic review of research spanning 20 years, from 1996 to 2016.
Wow, 2 decades. And it specifically looks at using writing in science classrooms from K through 12.
And this review was done by Margarita Huerta and Tiberio Garza.
Okay.
It's titled Writing in Science, Why, How, and for Whom? A systematic literature review of 20 years of intervention research, 1996-2016.
Catchy title.
It is.
So what makes this review particularly interesting and why we wanted to do a deep dive on it is its focus on comparing how writing is used with English language learners, so ELLs,
Right.
versus students who aren't ELLs.
Yeah, considering all the challenges ELLs often face in science education and the big push for equity these days,
Yeah,
understanding these differences is, well, I think it's crucial.
totally. So our mission for this deep dive is pretty straightforward.
Okay.
We want to understand what this research says about why and how writing can be such a powerful tool for learning science. For all learners, of course.
Of course.
But we're really interested in those nuances,
Right.
those unexpected differences in how writing is approached when you bring ELLs into the mix.
Yeah, that's a great point. And, it's interesting. The way we see writing's role in science education has really evolved over time, wouldn't you say?
I'd say so.
The review definitely points to a significant shift in perspective.
Okay, so what was the traditional view?
Well, historically, writing in a science class was mostly about demonstrating knowledge. Like, okay, you've learned this, now write a report to prove it.
Yeah, like the classic lab report. You do the experiment, then you write up what happened.
Exactly. Just a way to show you understand, like a final stamp of approval.
But you're saying that's changed.
Oh, it's definitely shifted.
Okay.
Now we see writing as more of a tool for building knowledge.
Mm,
Science isn't just about memorizing facts.
right.
It's about actively seeking understanding. And language, through writing, is how we really shape and refine our thinking.
That makes a lot of sense. If science is all about constantly seeking knowledge,
Right.
then the way we use language, especially in writing,
Yes.
to explore and explain our ideas, that's got to be fundamental.
Absolutely. And this is what's led to frameworks like Writing to Learn
Okay.
and Writing in Science.
Yeah.
They're related, but there's a subtle distinction, Writing to Learn, that really emphasizes the process of writing. Like how it helps students clarify their thoughts, get their ideas organized, engage with those concepts on a deeper level.
So it's less about the final product,
Right.
more about what's happening in your head as you wrestle with the ideas on paper.
Exactly. And then Writing in Science recognizes writing as part of how science knowledge is constructed. The way scientists use specific writing structures and strategies, like in lab reports, with evidence and a very specific way of reporting results.
Mm.
So Writing to Learn might be more like your personal notes while you're figuring something out. Writing in Science is about using those specific forms of scientific communication. Does that make sense?
Yeah, that clears it up.
Good.
Okay, so writing isn't just a way to show what you know. It's part of how you get to know it in the first place.
Right.
But why is this connection between writing and science so fundamental?
Well, the review really zeroes in on the importance of language in scientific literacy. It mentions Wellington and Osborne, who argue that you have to know and understand the language of science to be scientifically literate.
Makes sense.
Like, you can't truly understand scientific ideas if you don't get the language used to express them.
It's like, I don't know, trying to build something with tools you can't even name.
Right. You might have all the pieces, but you can't really put them together.
Exactly.
So language is key. It lets you articulate your conceptual understanding.
So even if you have this gut feeling about a scientific idea, you have to put it into words.
Okay.
Spoken or written. That's how you really solidify your understanding.
Absolutely. And this review also brings up Norris and Phillips' idea of the fundamental and derived senses of scientific literacy.
Okay, what's that all about?
So the fundamental sense is about being able to actually read and write scientific texts, like being able to engage with how scientific knowledge is communicated.
The skills, you mean?
Right.
Okay.
And then the derived sense is about actually knowing the science content itself.
So one's the skills and the other's the knowledge.
Yeah, precisely. And they make this point that science wouldn't even exist as we know it without language.
Hmm.
Language is how we communicate and shape scientific knowledge, even generate it, you could argue.
So it's not just about science, it's essential to science.
Right.
Now, the review also talks about a triad of challenges that are especially important for ELLs.
Yes.
What are those?
The triad includes academic language,
Okay.
conceptual understanding,
Okay.
and educational practices.
So 3 big interconnected factors. And the review says these are often linked to the achievement gap between ELLs and their non-ELL peers in science.
Exactly.
Okay, let's break it down. First up, academic language. How is that defined in the context of science?
They define it pretty broadly. It's the cognitive, linguistic, cultural, and discipline-specific features of discourse you find in school and beyond. So in science, it's the language used to teach and the language students need to learn to understand and do science. Like using complex sentence structures to explain a concept, that kind of thing.
So it's not just everyday language.
No, not at all.
So what are some examples of academic language in science that might trip up students, especially ELLs?
Well, they give a few examples. There's general academic vocabulary, words like analyze, you see those across different subjects. Then there's technical vocabulary that's very specific to science, like deciduous.
Okay.
And then you have everyday words that have different meanings in science, like school, like a school of fish.
Right, totally different from a school building.
Exactly. And then there's syntax, right? The grammar,
Mm-hmm.
like passive voice, which is common in science writing.
Yeah.
Or specific ways of talking about categories and drawing conclusions.
Yeah, that can get tricky.
Definitely. And while all students need to learn this academic language, ELLs often need an even higher level of expertise to keep up.
Which makes sense because they're basically learning the science and a new language at the same time.
Exactly.
Okay, so that's academic language. The second piece of the triad is conceptual understanding. How does that factor in?
So conceptual understanding is basically grasping the knowledge, the ideas behind a topic. And it's crucial in science, but ELLs might face some extra hurdles.
Okay.
Their native language and their cultural ways of thinking might be quite different from what's expected in a science classroom.
So it's not just the words, it's the whole way of thinking and organizing information.
Yeah, exactly. And the review talks about this concept called instructional congruence.
Instructional congruence. Okay.
It's about teachers understanding and valuing students' backgrounds, their everyday language, their ways of thinking.
Right.
But at the same time, teaching them the academic vocabulary, the structures, the practices of science, so they can bridge that gap.
Like building a bridge between what they know and what they need to know to succeed academically.
Exactly. And unlike many other students, ELLs are often learning the science content and a second language simultaneously. That's a huge cognitive load.
It's got to be exhausting.
It is.
Okay, so we've got academic language and conceptual understanding. What about that third factor, educational practices? How might current teaching methods sometimes fall short for ELLs?
The review argues that for real equity in science education, all learners, especially ELLs, need proper scaffolding, and they need plenty of opportunities to actually use language.
So both speaking and writing?
Yes, both. And the problem is current methods don't always provide that.
So it's not enough to just present the science. You have to actively incorporate language development into the teaching.
Right.
Okay, so with those challenges in mind, what did the review find about the impact of writing interventions in science classes?
Well, overall, it supports the writing to learn idea pretty strongly, which basically means that using writing to deepen your understanding of science actually works. So the learner out there, writing can be a great way to solidify your science knowledge.
That's reassuring.
It is. But the review also points out that the research is heavily influenced by a small group of researchers,
Oh, interesting.
like Hand and colleagues who mostly focus on non-ELLs and the science writing heuristic, and then Lee and colleagues who've done a lot of work with ELLs and interventions that integrate language arts and science. So our current understanding is kind of shaped by those specific approaches.
So it's important to keep that in mind as we look at the findings.
Definitely.
So let's talk about conceptual understanding first.
Yeah.
What did they find for students who aren't ELLs?
So the interventions that use the science writing heuristic,
Okay.
mostly in middle and high school, they showed some significant improvements in science test scores. And the science writing heuristic, it's basically a framework. It guides students through activities that help them build their understanding of science through writing.
So it's a very intentional way of integrating writing into the science learning.
Exactly. But the review also found that the SWH's effectiveness varied.
Really? How so?
Well, when it was implemented well, it helped reduce the achievement gap between high-achieving and low-achieving students.
That's great.
It is, but the impact was less clear for students with IEPs or for gifted learners.
Interesting.
And the type of writing task also played a role.
So one size doesn't fit all.
No, definitely not. It depends on the context and the students.
Makes sense. What about the qualitative findings? What did those tell us about non-ELLs?
Qualitative studies found that after writing interventions, students' written tests showed a deeper understanding of the science concepts, like writing helped them revise their knowledge.
Okay, so the act of writing helps solidify the knowledge in their minds.
Uh-huh.
Now, what about ELLs? What did they find about their conceptual understanding?
Most of the research on ELLs focused on third and fourth graders, and they often used interventions that combine science and literacy with writing as a key component.
Okay.
And these interventions often included like curriculum materials aligned with standards, teacher guides, learner booklets, professional development for teachers.
So a very comprehensive approach.
Yeah. And they found these interventions led to big improvements in science test scores.
So for the learner working with young ELLs, this suggests integrating science and language arts and including writing can really help.
Exactly.
What kind of writing were the ELLs typically doing in these interventions?
A lot of it was writing summaries of experiments, but the way they analyzed the ELL's writing was different from the non-ELLs. With ELLs, they focused more on linguistic skills.
Okay.
Like, were they using the science vocabulary correctly? Were they using the right sentence structures?
So they were looking at how well they were using the language to express their understanding.
Right.
Interesting. What about academic language itself? What did they find for non-ELLs?
Qualitative research showed that writing helped non-ELLs become better at argumentative writing. You know, constructing arguments,
Yeah.
linking claims and evidence.
Like thinking like scientists.
Exactly. And there was a study with 8th graders writing about streams.
Okay.
And they got much better at using evidence to back up their claims after the intervention.
So they weren't just stating facts, they were learning to reason scientifically.
Exactly. And quantitative studies also showed a connection between writing and deeper understanding. They used rubrics to assess things like use of evidence and science content, and they found a strong correlation between good science understanding and good writing.
So the writing was helping them understand the science better and communicate that understanding more effectively.
Right.
What about academic language development for ELLs?
Well, remember how we talked about how they analyzed ELL writing,
Mm-hmm.
focusing on language skills?
Yeah.
They found that higher quality science writing and stronger academic language were often linked to better conceptual understanding.
So the language skills and the content knowledge were intertwined.
Exactly. And some studies also found improvements in ELL's oral language, vocabulary, and reading comprehension after writing interventions, though the results varied depending on how they measured these things. And there's this one study that focused on multiple drafts for ELLs, which showed how connected their writing development was to their content knowledge.
Makes sense. The more you write, the more you revise, the more you think about the ideas.
Uh-huh.
Okay, the review also looked at trends in the types of writing interventions used. What were some key differences between interventions for non-ELLs and ELLs?
One big difference was the emphasis on the writing process. Studies with non-ELLs often involve the whole process: brainstorming, drafting, revising, getting feedback, and producing a final product. And teachers would model writing strategies and give feedback.
So it's very interactive and supported.
Yes. But studies with ELLs rarely mention this kind of structured writing process. The only exception was that one study on multiple drafts.
Interesting. So for non-ELLs, writing was often treated as this ongoing process, but for ELLs, it might have been more of a one-time task.
Yeah, that's a good point.
What about scaffolding? What kinds of supports did they use?
Both groups of studies used scaffolding. For non-ELLs, they did things like teacher modeling, having students write for a specific audience, combining talk and writing, and using the science writing heuristic as a scaffold itself.
Okay.
And they found that using 2 or more scaffolds led to better results.
So it's like layering the support to make the writing and the science more accessible.
Exactly. For ELLs, combining talk and writing was also found to be helpful. And, importantly, using their home language as support.
Which makes sense, using their existing linguistic resources.
Right.
Okay, what about the quality of instruction? Did that affect the effectiveness of the interventions?
Research with non-ELLs definitely showed a link between instruction quality and intervention effectiveness. Like with the science writing heuristic, when it was implemented well, it really helped close achievement gaps.
Okay.
But when teachers didn't give good feedback on student writing, it hindered learning. So the intervention itself is important, but so is how it's taught.
It's about the execution, not just the plan.
Exactly.
Did they look at instruction quality with ELLs?
Not as much. But they emphasize that culturally and linguistically relevant teaching is essential for ELLs. One study that didn't use home language support found that ELLs didn't benefit as much, which shows how important that aspect is.
So tailoring instruction to ELLs as backgrounds is crucial.
Absolutely.
Okay, let's shift gears a bit. Were there any differences in how the studies themselves were designed for ELLs versus non-ELLs?
Yes, actually.
Tell me about it.
The non-ELL studies were more internationally diverse. The ELL studies were mostly in the U.S., and ELL studies were more often in urban, diverse schools with more low-income students.
Okay.
And they looked at different grade levels, too. More upper elementary for ELLs, more middle and high school for non-ELLs.
So the context of the research was different?
It was, and the types of studies they did were different, too.
Oh, how so?
Non-EL studies used mixed methods more.
Okay.
Combining quantitative data like test scores with qualitative data like interviews or analyzing student writing.
Right.
They also use quasi-experimental designs more, which try to figure out cause and effect, but they're not as strict as true experiments.
Okay.
ELL studies often collected data for longer periods, sometimes up to 4 years.
So they could look at the long-term effects.
Exactly. And they measured things differently, too.
How so?
Non-EL studies often treated writing itself as a measure of learning. Like, they'd develop rubrics to assess how well students could write scientific arguments.
Okay.
EL studies would also look at conceptual understanding through things like unit tests,
Right.
but they'd also look at broader language measures like grammar, vocabulary, reading, and oral language.
So a broader focus on language development.
Right, which makes sense because with ELLs, you're often trying to develop their language skills alongside their science knowledge.
Right. It's all connected.
It is. Now, looking at how the research changed over those 2 decades, what kind of trends did they notice?
It seems like there was a shift in focus, especially in the research with non-ELLs.
That's right.
Like in the beginning, it was about the why and the how.
Exactly. In that first decade, they were mostly trying to understand how writing helps with scientific thinking. Like, what's actually going on when students write about science?
So more of a deep dive into the process.
Yes. And then in the second decade, they shifted to measuring the effects of writing. Like, how much does it actually improve science achievement?
Okay, so more quantitative.
Right. And they also started looking at different types of writing and how teacher quality affects things.
So a move towards more measurable outcomes.
Yeah. Now, the trends in ELL research were a little less clear.
Okay.
They seem to jump into those large-scale quantitative studies more quickly. Yeah, without as much of a foundation of theory about writing for ELLs. And while they did try to use more rigorous methods in the second decade, it wasn't as clear of a progression from exploring the process to measuring the effects.
So it sounds like they maybe jumped into measuring impact without fully understanding how writing works for ELLs.
That could be. And the review talks about how these trends relate to this idea of writing as a learning process. Back in 2003, Yor and others pointed out that this idea of using writing to actually learn science was just starting to get popular.
Okay.
And this review suggests that idea has taken hold more in the non-ELL research, especially in that second decade. They were focusing more on the writing process, on revision, on audience, but a lot of the ELL studies still seem to see writing more as a way to record information or show what they already knew, not so much as a way to actively build new knowledge.
So the writing to learn aspect might be missing for ELLs.
Yeah, potentially. So, taking all of this into account, what does this review tell us about writing to learn in science? What are the big takeaways?
Give us the TLDR.
Okay. The big picture is that writing is powerful. It can help all learners develop scientific literacy, both understanding science concepts and using the language of science.
Okay.
And it seems like there's this back and forth. You learn the language, you understand the content better. You understand the content better, you can use the language more effectively.
They build on each other.
Exactly. And the review also highlights how writing can be integrated into scientific inquiry for both ELLs and non-ELLs.
Okay.
And the most successful interventions seem to involve collaboration, feedback, taking into account individual needs, especially for ELLs, like their language background and proficiency.
So it's not just about the writing activity, it's the whole learning environment.
Exactly.
So what does all this mean for educators? What are the practical takeaways?
Well, first off, everyone should be using writing in science.
For all learners.
Yes, but it's not a magic solution on its own. It
Oh,
has to
yeah.
be part of a bigger system.
Right, it has to be intentional.
Absolutely. So the writing activities should be planned out, scaffolded, and aligned with the science content. And for ELLs, you absolutely have to use culturally and linguistically relevant teaching. And think about what kind of writing is appropriate for different ages and skill levels.
Mm.
The review pointed out that there's not much focus on argumentative writing for ELLs.
Oh, interesting.
So that might be a good place to start, maybe with sentence frames or something to help them get started.
That makes a lot of sense. So what about future research? What are the gaps that still need to be filled?
Well, one big difference they pointed out was that focus on the writing process.
Mm-hmm.
Non-ELL studies did that a lot more than ELL studies.
Okay.
And they also looked at academic outcomes differently. Non-ELL studies focused more on how writing shows conceptual understanding. ELS studies looked at more specific language skills. So they suggest some areas for future research, like we need larger, longer-term studies, especially for non-ELLs, in more diverse settings, maybe internationally. And they say we should adapt things like the science writing heuristic for younger learners.
Oh, that's interesting.
Yeah, maybe using drawing and scribing as ways to lead into writing.
So combining literacy and science early on.
Right. And for ELLs, we need more focused writing interventions that really analyze the writing process itself. And they say we need stronger research designs to figure out if writing is actually causing the learning gains, especially for ELLs.
Makes sense.
And they say we need more research in understudied contexts, like rural ELL communities, and more research on integrating science and writing in early childhood.
So lots of exciting avenues for future research.
There are.
So after all of this, what's the main message we should walk away with?
Writing is a fantastic tool for learning science, for everyone.
Okay.
But the key is how we use it, especially for ELLs. We need to understand that better. And we need to see writing as an active process of building knowledge, not just proving what you know.
So it's about the journey, not just the destination.
Exactly.
Well, I hope you, the learner, have a better understanding now of this whole writing and science thing.
I hope so too.
We've covered 20 years of research,
A lot of information.
and maybe you've got a few aha moments along the way.
I hope so. And now, here's something to ponder.
Okay.
Given all these differences in how writing is used for ELLs and non-ELLs, what's the biggest missed opportunity in science education right now? That's something to think about.
Something to chew on.
It is.
Maybe it'll even inspire you to check out some of this research yourself.
I hope so.
Well, thanks for joining us on this deep dive.
It's been a pleasure.
We'll be back soon to explore more fascinating topics with you.
We will.